Good evening and welcome to the BTS November lecture. Tonight, I am very pleased to invite Dr. Keith Bowers to deliver the Harding Memorial Lecture for 2020, Tunnelling in a Changing World. Keith Bowers is a specialist in delivery and operation of major underground transport infrastructure. He is currently the Tunnels and Systems Director for Highway England's Lower Thames Crossing. This programme involves driving 4-kilometre long twin highway tunnels under the Thames to provide a new connection between Kent and Essex. The product will be the UK's largest highway tunnel and will require some of the world's largest ever tunnel boring machines. Keith was previously Head of Profession for Civil Engineering and Built Environment at Transport for London, and before that, London Underground's Tunnel Engineer. At TfL, he was involved in delivery of tunnelling projects for London Underground, Crossrail, and on the highways at Silvertown. In his earlier career, Keith was involved in delivery of the HS1 and Thameslink tunnels as part of the Channel Tunnel Rail Link project. Prior to that, he was involved in ground engineering R&D at the UK's Transport Research Laboratory, TRL. He remains involved in research through the Cambridge University Centre for Smart Infrastructure and Construction. Keith is a Fellow of the Royal Academy of Engineering and also of the ICE, IMMM and Geological Society, and I welcome Keith this evening to give this lecture.
Good evening, and thank you for the invitation to present this year's Harding Lecture. Greetings too to many friends and colleagues that I haven't been able to meet in person for what seems a very long time now, and here's a reminder of where we might have been tonight, but probably more as it looks tonight. And the second image here is from the last time I spoke to the BTS, which was actually on the occasion of the Christmas debate in 2015, when Ross Dimmock and I enjoyed sparring over the merits of shotcrete for various tunnel solutions, ably chaired by Roger. My theme tonight is changes affecting our industry and the innovations that we make within the industry. But just to give you an idea of my viewpoint, here's a few images from my career. I've been around tunnelling for about 30 years now, and mainly big transport tunnels, roads, railways, a mixture of technologies, TBMs, sprayed concrete, a bit of hand mining and various other things. And even some practical contributions. Down in the bottom left corner, you can see me surveying many years ago when I had rather more hair than today. But going back to that debate with Ross, the starting point for some of my thinking for this presentation was actually out of some of the images we looked at there. This is a slide from that debate, hence the BTS Christmas baubles in the corner. And these were some images of things which I think we felt represented practices we've since improved upon. But I was looking at one of these images in particular. This is a scene in a tunnel I worked in nearly 30 years ago. And the interesting thing about this was seen as great innovation. This was the latest thing because this was the application of the new Austrian tunnelling method into a UK project. The photo looks rather unclear, but that's not a criticism of the photographer. The reason it's like that is because of the amount of dust in the air. The dust is from the dry mix shotcreting. You can see the nozzle man standing, holding a handheld nozzle, spraying dry mix onto the right-hand side of the heading. He's got his back to the plant, which is evidently moving. And if you look very closely, you might just be able to make out that the plant is actually a cherry picker, and in the basket of the cherry picker are a couple of people working. I was one of those people. We were wiring up instrumentation in the tunnel. There's lots of things about this photo that we wouldn't want to replicate today. So some questions about our industry. Is it an innovative industry? What are our successes? And what are our challenges for the future? And I want to think about those a bit more. But first of all, let's just think for a minute or two about the nature of innovation. Is technical innovation an easy thing to do? Well, I would suggest probably not. Here are some examples of technical innovations which weren't completely successful. Hopefully you'll recognise the different things here. The Titanic fairly obviously didn't pan out quite as planned. In the civil engineering domain, the bridge at Milford Haven was something of a disaster. And in the middle, two things which were successful in narrow technical terms, but much more challenging from a commercial point of view: Google Glass and Betamax video recorders. And they demonstrate, I think, the lesson to us that there is much more to successful change than just the technology itself. Is innovation any easier in tunnelling? Well, one of the lessons I learnt working on the London Underground for many years was that tunnels were actually fantastically reliable assets, long-lived, and not much went wrong with them, but some things did go wrong. And when things went wrong, there was one consistent factor. Almost always the thing that didn't go well was one of the first attempts at use of a particular technology. It was when the technology was young. So we obviously learn over time. Here's some examples of that. The top right, the Heathrow collapse, was of course another example of sprayed concrete technology in some of its earlier usages in soft ground in this country. Below that, there's some spalled segments from one of the first expanded ring designs on the Underground. More about that later. And then the other two images, one is the one in the center is an enlargement of a detail, but the image here is showing an opening in a cast iron tube tunnel. And if you look closely at that enlarged image in the middle, hopefully you can see that what has happened is the lintel has buckled. The lintel was inadequate for the load. The twist in the tale is that it buckled 100 years after it was built, demonstrating the time-dependent loading effects in the tunnels. But if you go in the tube tunnels and look at more recent openings, you'll find the lintels are much more substantial. So the danger time is perhaps when you first apply a new technology, but of course that's when you're trying to get the benefits as well. Sometimes what you need is just a bit of persistence. This image is an early attempt to put a spiral escalator into a former lift shaft in a tube station a century or so ago. At the time it was a failure. They couldn't get it to work, and the details are now lost in the mists of time. But people have kept on with the idea, and in consequence, one thing you can now find is spiral escalators that work. They're relatively common in some parts of the world. It's important to recognise there is a human dimension to this as well. I've mentioned persistence there. I think there are two sides to the way people tend to think about innovation and change. There's the innovator. He or she will be full of enthusiasm, excitement, and will see all the upside benefits of adopting the new product, whatever that may be. And I've seen plenty of examples of that over the years, some of them making proposals to me about how we might better do whatever it was that was the challenge of the moment. But then I've also seen the other side, perhaps the manager who's charged with implementing the change. There is a downside that some people perceive. It might be concerns about the cost or whether it will work, whether there will be a return on the investment. They're all perfectly reasonable concerns, of course. But what it emphasises to me is there's a bit of importance we need to attach to some of the softer skills as well as the technology when we think about change. Sometimes change happens very suddenly, sometimes it's imposed on us. An obvious example is, of course, the pandemic that we're currently experiencing. Here's a graph of the usage of the world's metros through this calendar year, and you can see immediately the point at which things changed and people stopped travelling. Human nature is to adapt very quickly when we have to and try and find a new normal. What we're probably not so good at is making changes when there is less urgency, when we can perhaps put it off till tomorrow. This is a nice example, though, that I saw the other day, and for me it made the point quite well about how we find a new normal quite quickly. A year ago, this sign, I think, would have been fairly incomprehensible. Who knew that we needed online farmers markets with drive-through pickup points? Now it's all too understandable. So innovation and change, they're driven obviously by a vision for some sort of improvement, but they're not always things that we welcome. They can be a bit risky and they need persistence. And that means it's perhaps quite easy to be a bit passive about changing things sometimes. But I think we have to recognise that sometimes we have a choice. Either we can get engaged and drive what happens, or we perhaps just have to wait passively and see what is done to us. So the first question I posed was, is tunnelling an innovative industry? This provides a good excuse to perhaps go back and look at some history of our industry, which seems entirely appropriate for a Harding Memorial Lecture, given Sir Harold Harding's interest in the history and development of our profession. So a definition of tunnelling that always appealed to me was fighting gravity. And as far as I can make out, we've been at it in the UK for about 4,500 years. If anybody can find an older example of British tunnelling, I'd be delighted to see it. But this is tunnelling for the purpose of mining in Norfolk. And of course, there was technology involved, albeit fairly rudimentary. Let's step forward to a time a century and a half ago when the industry was really getting dug in the development of London. This is from the construction of the first metro in Britain. And you can see, if you look into this image, evidence of all sorts of ingenuity, equipment, temporary works, steam engine or two probably. Lots of things being applied to the challenge of creating a railway through the city. Of course, there were lots of things probably that weren't being addressed at the time. The environmental impact was, I would suggest, perhaps significant. Just imagine if you lived in one of the houses in the background and this was happening in your street. Health and safety, probably not quite where we would like it to be today. And things like carbon, of course, probably not recognised in any form at the time. So there was lots they didn't know and didn't consider, but there was lots they were achieving, and you have to admire the enthusiasm they evidently put into the task. And of course, one of the great innovations and developments in the tunnelling industry has been the development of tunnel boring machines themselves. We're probably all familiar with the story of the Brunel's first tunnelling shield under the River Thames, and many of us could probably trace lots of steps in the development of machines since, through to things like the huge machine at Cheplack Cock, illustrated here. There's lots of smaller innovations you can trace in our industry too. We like we like giving things names, and I rather liked this example of the Swedish method. But this was advertising from the 1950s, and what it was highlighting was the combination of two technologies: compressed air, which have been around for a century or so in construction applications, and tungsten carbide drill bits. And the resulting equipment required a macho Swede with no PPE again, but was the greatest thing at the time, clearly. And you can carry on in a similar vein. Other things in London, ground freezing, quite a notable piece of technology in its own right, that from the Victoria line. And an image of this control room, which I've always been rather fond of, having spent a lot of time there. But nearly 20 years ago, this was what we thought state-of-the-art computer monitoring looked like. And it was pretty effective. But we do still like playing around in the muck. There are some things that we've struggled to find better answers to than the traditional ones. We'll come back to this chat a bit later. So yes, I would argue tunneling is an innovative industry. We can demonstrate a growing toolbox of techniques. We've got more ways of fighting gravity, if you like. And we do faster and bigger and different conditions, different places. So you can trace the developments we've made. But I'd also observe that quite a lot of our changes are perhaps quite slow, sometimes iterative, reactive. Old habits die hard, and that's something to bear in mind, I think, in a time when some of the changes seem to be coming on us thick and fast. We've developed a saying in my team, in my current project. We look at the environment we work in, and we describe our state as being a steady state of continuous change. I think you could apply that quite well to our industry as well. I think we are used to being in an environment where we are continuously and steadily changing. So what are our success stories now and in recent times? Clearly, one way of measuring our successes is to look at what we've achieved, the projects undertaken and the tunnels successfully completed. And illustrations here from Crossrail and Tideway are really good examples of what we can do with our tunnelling. If we think about different ways of measuring what we've achieved, we can evidence the claim that we've got bigger. This is a slide that we prepared originally some years ago now, but it traces the growth in our shield-driven tunnels over time, from the Tower Subway when we were down at around 2 meters up to some of our modern railway systems where we're much larger. And now the project I'm currently working on takes that further still. So it's easy to measure and demonstrate that we can do more than we used to be able to do. We can also do complexity. Tunnel spaghetti was a term that we coined, I think, originally at King's Cross, which is the top right image here. But these are all images from London Underground stations we've worked on in the last few years. And our ability, I think, to create these complex networks of tunnels winding round one another, but without disrupting one another, is a truly spectacular achievement, really. And it's perhaps a shame that most people don't see the complexity of what has been done. Any shape you want was famously something that was promised when we were working on the previous version of Crossrail in the 1990s. The suggestion was that once you had sprayed concrete technology, you could have any shaped tunnel you wanted, which felt dangerous at the time, particularly when it was mentioned in conversations with the architects. But anyway, we have created some very complex forms and shafts, openings, The middle image here is wrapping round existing tube tunnels with new tunnels coming in. So we've achieved considerable flexibility in what we can form underground. Also, our construction processes have advanced greatly. We've got things like escalators on the left-hand side of the image, where we've developed various different solutions for mechanizing work that traditionally could only be done by hand. And we've got better at some of the related things. Our dust and noise control has been a key consideration underground, and we've changed plant and systems to get much better results on that. And we've also improved our quality control in general with things like off-site mix control to increase the amount of our work that we can accept immediately as permanent works, where traditionally or historically it would have been condemned as temporary works only. We've achieved some other things too. Reducing impacts, and particularly ground movements for urban tunnelling, has been a big subject area and something I've worked on a lot in my career. 25 years ago, the big achievement was to take the Jubilee Line extension past Big Ben without tipping the tower over. Compensation grouting, various measures there were used to deliver that work very successfully. Then more recently, we've got better with our control, but we've taken on bigger challenges still. I've done a number of projects over the years where we've had to mine under escalators, which are very precise machines and very intolerant of movement. And we can now fairly consistently deliver major tunnels under systems like that without disrupting them and without necessarily resorting to solutions like grouting. And then this is something which is a relatively recent development, but one that I think was very important at the time. This is an example taken from Bank Station, but a number of projects have now done this. In the left-hand image, you see the tunnel face advancing, and within that face is a very substantial pile. It's actually an end-bearing pile, and that pile is carrying a building above. On this project, through improvements in our techniques, we've been able to mine through those piles to intercept them, to support the building loads, and pass the tunnel underneath the buildings without causing damage to the buildings. That's really important when you're working in a congested area like Bank or any city centre. And it's really significant in terms of the way we plan future schemes. At Bank, we were able to superimpose the idealized railway alignment on the city layout, and because we could, where we had to, intercept piles and manage them, we were able to optimize the railway alignment. Historically, we'd have struggled to wiggle through and ended up with a very poor railway. So that ability to deal with the structures we interact with has made a real difference to how we plan future schemes, and has a dramatic impact when one comes to alignment for a new project through the city. And all of this work contributes dramatically to our cities and the world about us. This is Canary Wharf as it was probably about 1980s. And of course, we now know it is a transformed area. And it's our ability to put infrastructure, and particularly underground transport infrastructure, in that has enabled that sort of transformation. So, have we got everything sorted from an innovation point of view? So what challenges do we expect to encounter as we move forward? I've suggested a number of things which I think are important to us in the future. Not necessarily all of the same weighting or the same types of issues, but things I think will make a difference. Let's start with carbon. Carbon is a subject that's in the news a lot at the moment, and certainly within the Institution of Civil Engineers, particularly a subject of a great deal of discussion. Hopefully we all appreciate the significance of carbon and the implications for climate change. The graph here illustrates the carbon trend over the last 800,000 years. And you can see that at the right-hand side of the graph, we're now spiking up well beyond those levels that have been detected in past times. So the change is real, and of course for climate and for our world are significant. If you haven't already listened to our new ICE President's presidential address, I would very much encourage you to do so. You can get to it through the ICE website. But Rachel Skinner has taken zero carbon and zero carbon for infrastructure in particular as the key theme for her presidential year. And she's highlighted in doing so that a very high proportion of carbon emissions are associated with infrastructure. So it's very much in the domain of the civil engineers in particular to address that challenge and think about what we can do differently. A little more on the specifics of the issue and why it's important to us. Carbon emissions here in various different sectors. The power industry has been greatly successful in decarbonising. Obviously that's to do with the move away from coal and into more renewables. And we're now in a place where surface transport, the transport systems in general, constitute the largest single contributor to our emissions. So we're right at the heart of some of these issues. And of course, it's now the law that we are aiming for a net zero position by 2050. Lots of discussion about what we can do and whether it should be sooner, of course. So what's it mean in terms of tunnelling? Where is the carbon in tunnelling? This is a generalisation, but based on various things I've looked at. And it's quite apparent that the embedded carbon in tunnelling is concentrated in a few areas. We're big users of steel, cement and concrete, and quite big consumers of energy. And those make up a large part of our emissions. There are then a whole mix of things which contribute the balance. So what can we do about it? How do we respond to Rachel Skinner's challenge? Well, there are the various measures that we can pursue. Firstly, of course, what can we do by design? If we build less or build more efficiently, then we will reduce our emissions. That raises, I think, some interesting challenges for us, particularly for our design, and questions like redundancy and design life and so on may come much more strongly to the fore. I think we need to be having more debate about what is an appropriate level of redundancy in some of our designs. I strongly suspect that some of our structures are, shall we say, somewhat more robust than might actually be required. And of course, carbon and cost link very closely, so it's really just a double incentive. It works together to look at design efficiency. I'm sure we're going to see much more focus and challenge around that as we go forward. There are other things. I've highlighted already the part that our materials play. There are alternatives in existence for many of the high carbon materials we use, but then we may be reticent about their use, and we will quickly get into discussions about standards and specifications and what's acceptable. But I think those are conversations we need to engage in. So a couple of illustrations here. One highlighting that alkali activated cements, which are much lower carbon, are now starting to come into use. As an example in London, in piling there. We could look at things like recycled aggregates. We might turn up our noses at some of it, but we might see opportunities in there. We need to be challenging these areas. And we need to look at our energy sources. Clearly, as consumers of energy, we can look at where our energy comes from and look to use renewables. But I think as well, there are some interesting questions that are quite specific to us as a sector. It's quite clear there are trends globally towards battery-powered equipment and vehicles, and also the press release here is illustrating commercial use of hydrogen fuel in vehicles. Those are both, it would appear, very good green solutions, lower carbon solutions, but both of them potentially pose questions about hazards in an underground environment. So I think there's a discussion we need to have developed further there. And then there's offsetting. And offsetting, planting forests or whatever to compensate for the carbon that we have embedded in what we've done. It's a valuable tool to us, but I don't think it should be the answer. It's a secondary response. We should be looking to solve the problem at source first and use offsetting as a tool to compensate where we struggle. So what are the next steps? A little while ago, I think I would have really struggled with this, but now I think I'm feeling it's a much clearer picture. We know that we need to consider carbon in our decision making. It needs to be there really alongside cost and time as the other two parameters that we love to use to measure things. And we need to follow good carbon management principles. We have now a PAS which sets out the way forward. It's not the full answer, it's a step along the way, but like a lot of things, if we start to measure and manage the things we can around this, then we will be en route to better solutions. So we should be routinely in our work going forward establishing targets, setting baselines, monitoring the emissions that are associated with our works. And all of that is now really in our grasp, especially if we use digital techniques to the full. There are also a few other sort of quite niche things that we might want to think about, but climate change does have some particular implications for tunnels. The image in the middle is the New York subway system flooded some years ago due to an exceptional storm. And then on the right, one of the airbag systems that has been developed as a response to that to plug tunnels. Resilience, I don't think in our infrastructure is an answer to climate change, but it is something we will need to think about more in our tunnels because we tend to put them in the bottom of river valleys and places like that where flood is a risk. And also, of course, there are some implications for the types of infrastructure we might need. So we find ourselves again with the growth in renewable energy, looking at potential pump storage sites, as in the top left image here. We see ourselves probably doing more schemes such as flood relief on the right-hand side of this. And even there is underground work associated with things like carbon capture and storage. So there are new areas where we may be able to apply some of our skills. We need to be monitoring these and seeing what we as an industry can contribute into these areas. So overall, carbon saving, yes, it's driving change in tunnels. It's happening and we do need to do things, but we are starting to get a much clearer map of the steps we need to take. We don't have all the answers. We'll need to come up with more and better solutions. It's a real challenge, but I think there is a lot of potential to innovate and improve fairly quickly in our sector. Let's change tack a little bit now and think about some different challenges that lie ahead. Let's think a bit about the actual assets that we create and use. What does society want from us as an industry? Well, sadly, perhaps they don't actually necessarily want lots of tunnels. What society wants is lots of benefits, lots of outcomes. And I think sometimes we're perhaps not as focused on that as we might be as a sector. So we need to get better at talking in these languages sometimes, particularly when we're developing the early stages of proposals. We also need to make a concerted effort, I think, to change our habits a bit. We can be quite siloed. This is a systems engineer's V diagram describing the life cycle of a project. And I think we don't always see the whole picture. We tend to like to focus in the design and construction sort of area, or a few of us in the operation and maintenance area. And it's all great and really important work. But as an industry, I think sometimes we could perhaps convey a broader vision. And there's lots of good stuff that we can be achieving. These are examples from around the world of using underground space to put transport systems underground and reclaim the green space in our cities. Clearly a very attractive, beneficial idea. There are things like multi-use tunnels. The smart tunnel here in Malaysia, a good example of a tunnel that was built intentionally with two different modes of use, road vehicles and water. This is great kind of planning and thinking that we should be arguing more strongly to carry forward, I think. The potential for multi-use assets must be beneficial to our society. And also, perhaps on a slightly smaller scale, there are questions around repurposing underground space. We actually have a surprising amount of disused underground space, but it's all assets. And I've just highlighted here on the left the example of the Queensbury Tunnel, which currently has a campaign running to seek support for renovation and perhaps conversion into a cycle route like the tunnel on the right here. And then there are new transport systems which may require or work well with underground space. We're probably all familiar with Hyperloop, which was celebrating its first passenger journeys earlier this week. And Magway, in some ways a similar system, but a proposed freight transport system in the UK. These are all examples of changing demands in society, changing uses potentially for underground space, and we need to focus on them. So all of these are examples of different uses, changes in current or potential use of underground space. And I think it's an area that we would all benefit from following. And I'd encourage you to support initiatives like Think Deep and Iticus in the ITA, which are promoting the potential applications of some of these things. And then there's a related set of changing needs issues around aging assets. And that's something that is quite specific to parts of the tunnel sector. This is a visualization of our infrastructure. So most of our infrastructure is the big block. It's already in use. It already exists. What we have in development is really quite small. So we need to take a whole life view of our assets. We need to look after the assets we've got, as well as create new assets in order to provide what society needs. If we take an example from the world of metros, this is a plot of the year of first opening of all the world's metros. And what you can see is over in the 1860s, we've got the London Underground, of course, right at the beginning. But then slow growth over most of the next century until the period really after the Second World War, when metro systems expanded enormously around the world, and the last decade or so more than ever. Now, the interesting thing to note is that the system's life expectancy for a lot of metro systems is probably of the order of 40 to 50 years. So actually what we're starting to build up now is a sort of bow wave of metros that will probably require renewal. And sometimes the deterioration of the assets does affect the structures themselves. So here are some examples from tunnels around 50 years old, starting to feel a bit tired. We're getting leakage, soil ingress, corrosion, that sort of thing. And it all ultimately affects the performance of the systems. If we failed to maintain these sort of structures, we would expect the systems they carry to start to become less effective. And here's another example of a structural deterioration in a tunnel of, again, around the 50 years age mark. Cracking and spalling. This was a section of the Jubilee line a few years ago, where an expanded lining was getting into some distress. This project was probably one of the most interesting I've ever worked on. It was completed a few years ago now, but what we ended up doing was removing the damaged concrete segments, that's what's going on in the image on the left, and replacing them with new iron segments. But the interesting thing about this work was largely undertaken at night. So although we were rebuilding the primary structure of the tunnel, we weren't disrupting the service. That took quite a lot of ingenuity. But it's an important one to note because it's probably the sort of thing we might expect more of in future years. And just to illustrate the point, here's another job I was involved in a little while ago, actually on the Washington DC Metro, and a similar problem, renewal of elements of the structure required and seeking ways of doing it with minimal disruption to the service. This is something that's going to repeat around the metros of the world as those systems that were built after the Second World War start to deteriorate. So when we look at our existing stock of tunnels and we think about what happens to them, what we observe, it's important to recognise that tunnels very rarely collapse, but they do deteriorate, and we should be anticipating that more of our workload in the future may well be refurbishing, renewing the assets that already exist. So now I'm going to switch to another challenge, or perhaps an opportunity more than a challenge, but the world of digital, which is something else that is changing very rapidly for us. Why is digital so significant? Well, here's a diagram from the Cambridge Smart Infrastructure Centre, and it seeks to demonstrate why digital enhancement is important. The top symbol, top arrow, indicates what we can do to enhance the infrastructure that's in use by physical additions. And the point is we can only add a small amount of new infrastructure at a time. But the bottom figure illustrates that if we make digital enhancements, if we apply digital technologies, we have the potential to change the performance of the whole asset base, the old assets as well as the new. So digital really presents us with a big opportunity to have a dramatic impact. So to use the language of the Cambridge Centre, this is what smart infrastructure is all about. This is bringing together our physical infrastructure with the digital infrastructure that we can now create, we can now use, in order to get much higher levels of performance out of the combined system. So let's have a think about where we are with digital technology. What are we doing today? And of course, the core of a lot of it is the use of 3D BIM increasingly and common data environments. We're getting used to that idea. We're used to seeing the data shared in this sort of format. But there's lots more potential beyond that with digital. There's a whole range of things that we should be developing and exploring together. Our digital platforms are a great way of sharing health and safety information. GIS provides us with a really good way of communicating ideas and layouts and basic information in all sorts of discussions as we plan works. 3D visualizations are proving very, very valuable in helping the wider society understand what we're proposing, what it will look like. And in just the same way as we can start to put a cost dimension into our models, we can now look at putting a carbon dimension in so that we can monitor carbon more effectively. We still have problems of burying ourselves in information, but actually digital provides great ways of managing that information and helping us make sense, whether it's visualizations like the thermal image graph here, data feeds into control rooms, or any number of different forms of dashboards of key information. It can all be done digitally very effectively. Wearable PPE is an emerging technology. Things like proximity sensors and health monitoring are potentially great measures to improve the way we look after our people. Modular construction, well, we're kind of kings of that already in segmental tunneling, but it's all enabled or helped by digital now. And potentially in the future, there's automation. This was an illustration from NCE earlier in the year of reputedly self-driving tunnel boring machines in Malaysia. And it just goes on and on, the potential. There's robotics. That's already in the tunneling industry with equipment for tool changes being developed and robotic earth moving plant. There's digital twins. Some of the works I showed you earlier have been replicated in digital models and tested in a digital environment. So when we combine all of these technologies, we have huge potential for change. Taken together, we have all the bits here of a digital revolution, but what we probably don't have yet is all of those bits joined up. And I think one of the changes that must be coming soon for us now is to get much more effective at integrating all of those parts into a single golden thread so that the information is passed seamlessly through the whole life of the infrastructure. I'm going to turn now to the last of the areas I wanted to talk about and just reflect for a few minutes on some of the people issues in our industry and what might be changing there. What matters to us about the people in the industry? Well, there's quite a few different things, aren't there? There's health and safety. There's mental health and well-being, which I think are getting much better recognised now than a little while ago, and that's just reflecting what's happening in our wider society. There's behaviour and the use of behavioural science, which has been helpful for some of us, but probably less widely known. And there are all the issues and questions that come up around equality and diversity and inclusion, which we also need to reflect on. So it's a broad area. There is a very serious reason why I wanted to pick up on people issues. These are statistics for the construction industry rather than just the tunnelling industry. But it's sobering to see that the construction industry has the highest suicide rate of any profession. Suicide is 6 times more frequent a cause of death than falls from height. And I think that's as strong a call for change as anything that we've talked about today. So we do need to focus more on our people and the well-being of our people. And there is some really good practice around our industry. Anyone who's done the EPIC training set up by Tideway will, I'm sure, recognise the value of that immersive training, aiming to improve our behaviours and our understanding around safety. There are other things that go on in our industry. I know from my own personal experience that good collaboration, good behaviours have always been at the heart of the most successful jobs. that generally the jobs that have gone best have been the ones where we've all shared goals. We've had a clear common focus. And that's a challenge to our management sometimes, and certainly to our contract forms. We need to work as an industry always towards more collaborative working and empowering people to address the real challenges rather than just fighting each other. We work best when we're all in it together. So I'd actually like to propose a change in addition to the smart infrastructure model that I showed earlier. I think the infrastructure that we're working with really is made up of three things. It's the physical infrastructure and the physical work that we do. It's the digital infrastructure and all the improvements that brings. But I think the people part of our infrastructure is as important as anything else. And it's taking the three together that we will make successful changes going forward. So people, for me, are right at the heart of this. We do have a great skill base, but we also need new skills and new thinking. We need the skills that come with that digital revolution. We need the skills that come with the understanding of the technologies around carbon. We need the skills to identify the future needs and uses of our infrastructure. It's all challenging and interesting and demanding work, but it's also good fun. I've enjoyed working in this industry, and I think we have a great positive prospect to offer to bring people into the industry now. I think that's really important, and when we are drawing people in, when we're recruiting, we should be thinking about that broader picture in what we present. So finally, to close, I just want to show you a short case history. Coming back to our friend who was doing the ham mining. We know the environment he works in. We know it's demanding, it's long shifts, it's hard physical work, perhaps stressful work too at times. How can we help him? What can we do to make it better? What would add some value to this? Well, fairly obviously anything that helps with health and safety, but particularly things that could potentially reduce fatigue and the associated risks, things that would improve his well-being. And in this age as well, we need to be aware of the need for legal compliance. Can we apply some innovation out of all the things we've talked about to help with this? So this is a note of appreciation to what I think was a really great piece of work that I saw done on the bank project by Dragados and London Underground working together. And it was a trial to monitor fatigue and see if what we could practically do to measure and then better manage fatigue in the workforce. And it used a technology based on a wristband, although there's a bit more behind it than just your average Fitbit. But particularly the wristband from Fatigue Science comes with a data set behind it that allows us to interpret the results much more accurately and give a much more effective and objective measure of fatigue and of the effectiveness of individuals at work. And there's a huge database behind this from which we have a quantified scale, so we can classify results and clearly understand where the risk is. The trials that were undertaken covered a range of shift patterns, an opportunity that was presented at bank. And therefore we had the ability to directly compare performance on different shift arrangements. And we did see differences. We could quantify the effect of certain shift patterns, certain shift lengths being better than others in that they reduced the amount of high risk time. The fatigue risk never completely goes away. We're dealing with human beings, but you can mitigate the risk down. And we could also start to understand some of the other things that were going on. We could look at things like sleep duration and various measures of effectiveness of individuals over the period of a number of shifts. This is really quite compelling data, And I very much hope this will soon be published in full through the. But the results from it allow us to make a very considered management response. We can recognise where the greatest risks are. We understand things like circadian rhythms. We understand when people perform best. And what happened at Bank was the application of the digital science, the methodology in the trial enabled a response, an intelligent response that it could adjust shift patterns, move tasks around, and therefore objectively reduce risk in the workforce. This is exactly the sort of thing I think we should all be striving to do more of in the future. So I commend that team and recommend that other people look into that piece of work. A really good example. And the outcome, of course, is that by bringing together these sort of considerations of the physical, the digital, and the people issues, we should have put our friend in a much better place than he was previously. So some concluding thoughts. I think the tunnelling industry is absolutely based on innovation. Change is normal. We're good at it. But the challenges that are ahead of us now are bigger and more urgent than ever, and we're going to have to work hard to respond. Sometimes it can all look a bit scary, but I think it's inherent in engineering, and certainly our sort of engineering, that there's an element of bravery and an element of persistence that is important. It's part of what we do. We also need to listen very closely to society's messages. We can't afford to ignore not just the immediate customer, but the wider requirements of our society, and we must respond to those things. We need to make the most of the opportunities that we do see. When we get new skills or methods or materials, we need to welcome them positively. Yes, we need to test, we need to be sure that they're right for what we're doing, but they are fundamentally our opportunity to get better in the future. And what we do in the future has to be so much more than what we did in the past. It has to be better. So an acknowledgement, thanks to all those who've helped me in various different ways in preparing this material. I hope you found something of interest in there, and perhaps will provoke some conversations somewhere down the way. As a closing thought, I've looked back quite a lot into history. I think what was developed in our industry 100 years ago was very impressive. What will we be remembered for in 100 years' time? Thank you.
Are you gonna share the screen, Divik? Fab. I think there was a question quite at the top as well.
We've swapped names, I see.
Oh yeah. Do you want to tell us when it's live, Divik, that they can hear? Okay, lovely. Okay. Well, thank you very much for that, Keith. I think if we could go now to questions, I think hopefully if people could put their questions in the chat, that would be great. And I think there were a couple that have already been filled up as we've gone. So I think I think also Divik's going to swap myself and Keith over. But I think if you could go back to the questions first, well, actually, I might be able to find it on my other screen. So I think the first question we've got, Keith, was from Danny Trupp. So a major innovation, financing tunnelling. Would you like to probably take a read and see what some of your thoughts are on this one?
I think if you take a global view of tunnelling, then certainly, yes, there are big innovations in financing, and it's quite interesting. There are very different approaches to financing in different parts of the world. I think PFI, for example, polarizes opinions very strongly as you move around the world. So there are some places, we know in the UK, under the current government, that PFI is not a favoured route, particularly for large infrastructure. The government's positively moved away from it. If we look to other parts of the world, there's a very different outlook on PFI. So I agree there are innovations there. There are certainly different approaches. I guess my take on it a bit might be it's in the category of things that are perhaps imposed on us often as an industry, rather than things where we can always make our own selections, and we can work within various models.
Okay. Let's see if we can find. I think we've got a couple of more. I think I can see one from Helen Natras. I've read of changes in engineering education, such as university courses, where A-level maths and sciences are not required for entry. What are your thoughts?
I think my immediate reaction is core. There are core disciplines that we need, which will not change, and we will continue to need numerous people with good scientific understanding. So those I would see it as core subjects. We might debate the route by which people get there, and I think we've got better at understanding that there are flexible career paths, and perhaps some people may follow different paths to qualification, but fundamentally we do need some of those skills. But I think the thing that perhaps concerns me more about our education at the moment is some of the other things which I think are becoming as important to us, but I'm not sure that they're all yet getting reflected in the training we're offering people. So I've talked quite a bit about various things in the digital world. Is our training of new engineers as comprehensive in all of those things as it needs to be? Because my feeling is digital will take up sort of more space in the working lives of our future engineers for various of the reasons I've been talking about. And therefore, we need to make sure we have a good, sound basis of training in that area. We probably rely quite a lot on the things we learn a bit ad hoc along the way. I think if we were revisiting, say, the curriculum for an engineering degree today, that would be one of my first challenges.
Some very good points there, actually, and I think for those that represents academia on that journey to an engineering course, I think that's key to note. Okay, let's have a look at the next one. So, how can we influence UK procurement models to reduce waste and man marking?
I think waste and man marking are two different issues in there. How can well, I suppose there's an argument that we're wasting time, aren't we, with man marking? But I come back to a couple of the things I've talked about. tonight, if we take a sort of a very direct view of wastage, then I think cost efficiency and carbon efficiency are inevitably things which go together and which will get growing focus in our procurement models as we go forward. I think we're in a time of change now. We tend to buy a lot of things sort of as a nation, not necessarily speaking specifically about tunnels, but we tend to buy a lot of things based on when it can be delivered and how much it's going to cost. I think we're not going to take away from those parameters, but I think we're going to add the carbon question more, and so that will tend to drive us in the direction of efficient use of resources and therefore less wastage. But the man marking part of it, which is about efficiency as well, I'd come back to what I was saying a little bit around the way we actually contract to do work and the importance of establishing collaborative ventures. All through my career, we've had lots of discussions in the industry. We've had Egan and Latham and things like that. We've had various types of alliancing and so on. I have been fortunate to work in some extremely good sort of allianced environments, and I know of others around. There's some admirable work in a number of our large client groups, sort of some parts of the water sector and so on. So I think I use the expression, we're all in it together. I think we need to look for contract forms where we are all working as one team as much as possible, where we're not fighting to get the money out of each other's pockets. We are working together to deal with shared risks. And that really is about how you set up those fundamental contractual relationships as much as anything.
Some good ideas there. I think the next one we've then got is from John Davis. Any thoughts on innovations in commercial arrangements, near past and future?
Well, I think that probably builds somewhat on what I've just been saying. An awful lot of what we do under our contracts at the end of the day is about managing risk, or managing technical risks, managing other risks. And if we can align our efforts so that we're all working together to conquer the risks, to overcome the hazards, then that has to be the best answer. And we can put contracts together in a way that sort of maximizes that effect. We should, in my view, aim to do that as much as we can.
Yes, definitely. So then what have we got next, Divik? We've got one here. So multi-use tunnels is an excellent idea and really quite simple in principle, but with multiple large infrastructure owners across the UK, not often done. How do you see this being promoted in the future?
I hinted a little bit at some of the frustrations I think sort of I see, and I'm sure a lot of us share from time to time around siloed organisations and so on. And you can take that at a national level. Fundamentally, the way we manage our infrastructure is we divide it up between many different agencies and owners. And therefore, it's a challenge that has to be taken at the top level. We need to get the different parties to work together. And I think what we can perhaps do as an industry, we cannot direct all of those changes, but we can make the argument, we can lobby. And there are probably some environments where there is, for example, common political authority for a number of systems, which we have in various of our cities in the UK. There are opportunities in areas where it's probably easier than others. I think it's probably quite a long-term journey, but I think it's one worth pushing on.
Absolutely. Where have we got next? Right, the next one is coming from Chris Hughes. How do you see post-COVID transport demand? Do you see a dip in infrastructure investment?
two different questions there, aren't there? Post-COVID transport demand. I'm not sure that I have an evidence base to argue it from, but what I would expect is that, or what I would observe is that most of our transport infrastructure is very long-lived. Most of it, metros and things, I've suggested, 50 years for a first refresh. We're building things that last centuries. And if you take a century view, then we expect COVID to be a small part of that. And, some of the effects we've seen may well reverse quite quickly. But we shouldn't underestimate that there will be changed behaviour. There has been some interesting stuff in the press just this past few days around people's potentially increased use of private cars and other modes of transport. I think what I would take from the whole COVID experience as far as public transport usage is concerned is the message that things can change and things can change suddenly. And we need to think about sort of scenario planning for different circumstances, perhaps. That it's been a bit of a wake-up call from that point of view. But I strongly expect that we will return to broadly similar patterns of use and growth of the transport system in due course. There was a second part to that, wasn't there? And I can't see it now.
It was, do you see a dip in infrastructure investment?
In relation to COVID, I guess I'm no more informed than many of you, but I would be surprised if in itself caused that for exactly the reasons I was saying. Our infrastructure investment is for things on a longer timescale, fundamentally, than we all hope and believe the pandemic will affect us for.
Okay. What have we got next? So how best can we mandate whole life carbon assessment on tunnelling projects? Does it need to be a contractual requirement to demonstrate efficient design and construction? And that's come in from James Boswell.
Yeah, the carbon management standards paths that we now have is of course pushing us in this direction. We have a significant difference sometimes between thinking about just design and construction phases and thinking about whole life phases. We can build things into our contracts, we can put measures in place. There's a great deal that's being done now with baselining and tracking carbon and so on. And those are the basic tools for controlling these sort of issues. I think almost the first priority is to get those measures in place and start tracking, because then we can have a much more meaningful, a much more informed discussion about what we actually want to do with that data, how we are going to use it going forward. So we're learning. My own feeling from the things I've seen is let's start measuring. Measuring's always a good way to start to manage something that you don't fully understand at first. Get the data flowing, see what we're doing, and then we can make good decisions about how we change it, how we influence it in the future.
I think the next one we've got in is from Charles Allen. So Keith, a lot of emphasis in this country is focused on shotcrete innovation. There has been no innovation in shotcrete materials for the past 25 years. It also has high carbon footprint.
I think Charles is being a bit provocative, saying there's been no innovation. I had some illustrations of some really quite poor quality shotcrete products some time back, and now we have good quality permanent works, relatively watertight, fibre reinforced materials. So a range of things have happened there. But certainly I absolutely agree with Charles that it has a very high carbon footprint. almost all of the shotcrete that we see. They are generally very high cement concretes. And I think shotcrete, sprayed concrete, I see being with us as a key sort of tool for tunnelling for quite a long time to come yet. But it's definitely in the category of things where we can look at the materials, we can start to challenge what's going into that mix. And I think, again, once we start to measure not just the cost, but also the carbon content, then we will start to recognise where we can perhaps use alternatives and bring that carbon footprint down.
I think we've got one more, have we? Got one in from Andrew Sendall. Bearing in mind the horrendous waste of shotcrete in SCL tunnelling, have you any thoughts in reference to graphene concrete, the new wonder material on the block?
I have to admit it's not a material I've studied. So I can't claim sort of expertise or make particular comment on it. But I do recognise what Andy's saying about the wastage. And again, I would argue that our practices have got better, but it's inescapable that there is a large amount of wastage. And one of the routes to efficiency must always be to use less material, as well as potentially using different materials. So I think we need to be open to the new wonder materials, whatever they are. We need to put them through appropriate scrutiny, but we certainly need to be looking very closely at anything that does appear to offer tangible benefits over the materials we're currently using.
Okay, I think we'll just give it a minute or so longer. I think we've got, I think a very useful comment has just come in. Oh, actually, we have got one more question. So I think if I could ask if you could put any last questions in the chat. So we've got one in from Frank. For Baker Street and Bond Street tunnel relining, when the trains ran at higher speeds in the tunnel to provide faster, more frequent services, how this affected performance of the expanded lining?
Yes, the short answer is it did affect the performance. Interestingly, it's an example of perhaps digital technologies getting more performance out of the infrastructure, but that particular line progressively experienced higher and higher traffic as the trains and signalling improved through there. In consequence, the higher traffic generated both more heat, almost certainly, and more ventilation. And part of the problem behind that particular issue with the ring was actually desiccation of the clays behind. The expanded lining was not watertight, so I remember at the time we described it as being like applying a hairdryer all the time to that structure. Eventually the clay desiccated and shrank away, and then the expanded lining really didn't work very well. So changes of use and changes in things we do with some of these tunnel assets are really quite important. Often our assets are very resilient, but we need to be careful if we use them differently. Things can happen and they can catch you out.
I think we've also got one in from Stefan Jefferis. It's very interesting to see the pictures of tunnels showing their age at 40-ish, the tunnels for which the expected life was probably much longer. Today we are looking to 120 years. Is this real?
In many cases, yes, I think it's easily real. Within London Underground, we talked quite a lot about the aspiration to keep our structures or to expect them to serve for 400 years. And that seems not unrealistic on many, but there are exceptions, as I illustrated there. And I think really what I would challenge people is not so much to think about nominal design life, which I've always found quite a difficult concept, I would encourage designers, in fact, in the London Underground standards, we ask designers to consider what the deterioration processes might be, what degradation was expected for a particular structure. I think that's a much more helpful conversation, and because it leads naturally to what maintenance interventions might you need to do. We don't generally want to replace our tunnels, we want to keep them working. So in most cases, we can make them last much longer as long as we understand what's going on with them. But I would just add one additional comment to that. I also showed that example from Washington, D.C. Washington, D.C. has a noticeably different climate to London. And some of the processes that cause us problems, things like corrosion and so on, do happen at very different rates in different places. So some systems will be more susceptible than others, irrespective of what design life we nominally provide for them.
Great. I think we've got another one that's just come in. So Neil Phillips, based on the fatigue work, do you think we should move to 3 shifts per day as standard? So 3 times 9 hours to allow handover.
Broadly, that was the conclusion we reached in the particular case of the bank project. There was quite a compelling argument for it. And one can demonstrate that things like productivity and so on need not be greatly adversely affected, can even be a benefit in some cases. But I think there is a caveat to that as well. I talked about those suicide figures for the industry. I'm sure a factor in that must be the itinerant nature of the workforce in the construction industry. And I do think we do need to be mindful of sort of what's going on in the whole 24 hours for the individual. Because actually the 8 or 9 hours at work might be the best part of the day in certain situations if we're living remote and so on. So broadly, I'm certainly personally, I prefer the 3-shift arrangement. I think we can show clear benefits, but I'm just a little bit reticent about wanting to apply an absolute sort of requirement around that, because I think we can do better than that. That monitoring of the people, that happens 24 hours a day. We're looking at the whole equation, and I think we need to have that wider view in getting to a conclusion about what's the right answer for a particular project.
I think, Divik, that concludes. I'm not sure if we've got any other questions. I think if you do have any other questions that you want to ask tonight, if you put them in the chat, Keith may be able to help with sharing some things in the future. So just want to take this moment really to thank Keith for giving us a very interesting and thought-provoking lecture this evening. He certainly set out some key challenges for our industry to consider, and also to really hold ourselves account for, with some excellent ideas of areas that we should really be focusing on. So I think a lot of food for thought passed to us tonight, along really with the key message and call for us all to stay open to change and stay flexible and listen about it, for us to really be able to take full advantage. And I particularly liked your part about staying courageous to get the maximum benefits. And as a result, I think you can see there's some wonderful comments we've received tonight, and really good to see so many interesting comments and questions. Thank you very much. So I think tonight we have just got a couple of announcements, which I think if Divik could work his way through the slides. So my first announcement tonight is that the MSc Tunnelling and Underground space at the University of Warwick is open for applications for entry in October 2021. This can be done as either a 1 year full-time or 2 to 3 year part-time course, and there are options to take some modules for a smaller award. There is a BTS bursary available, and I would ask for people to look at the BTS website for more details. And I think after tonight's lecture, particularly some links of how you can take forward some of Keith's ideas and make sure you're at the forefront of developing some of those ideas for our industry in the future. And for more information on the funding opportunities, I think there's another bullet points in there, Divik, with the web link. Yeah, if you follow this address, you'd be able to find out more information, and also look out for some flyers that will be sent round in the near future. So one of the next things we have got tonight is the BTS bar. It's been a long time since we've been able to see you in person. We are trialling tonight, as we have had over 400 people join us tonight on this talk. Not quite sure how that's going to work on a Zoom link, but it'd be interesting to see if many of you could join us in a virtual BTS bar. And if you follow this link, or if you're really fancy, are able to scan the QR code, it should take you straight there. So hope to see many of you on that call shortly. Another announcement is, many of you know, we mark National Tunnelling Day, and this year that falls on the 4th of December. So if you could look out and follow our social media accounts for information on ways to celebrate. It will be a virtual day here, but if you could post your tunnelling photos with hashtag Tunnel Day UK, we would really appreciate it, so we can get the message out all about tunnelling. Next item is our next lecture is on the Thames Tideway Tunnel. It's a project update from Andy Older, and also from representatives from the 3 contacts, and that is on Thursday the 10th of December. We also have title TBC. Our lecture in January will be from the Robbins Company, and that is on Thursday the 21st of January, and we really hope you can join us. Also, just another quick reminder, we are still developing the BTS at 50 book. Hopefully, if you've been joining us for most of our lectures whilst we've been online for the last few months, you'll have seen these announcements. But progress is still developing, but we are still interested if people want to join and volunteer to help contribute to this book. Please contact Ken Spivey, Sarah Langley, John Corcoran, or Anita Wu. We are still looking for volunteers and support. And if you would really like to help us and you're interested in sponsoring the book, you will get your company's brand in front of all levels of tunnellers in something that is there to commemorate 50 years of the BTS. And who wouldn't want to be on the back cover of that book? So we still need volunteers, and we need sponsorship to finish the job and make it to be something that we can all be really proud of. And then the next one is, hopefully all of you found us easily tonight on YouTube. If you could make sure you subscribe to the channel, you will always get the notifications of when the lecture starts, and you will never miss a recording. And on that note, if you could all join us in the bar, thank you very much and good night.